Hi students, myself Dr. K.S.Rangasamy, working as a professor in the Department of Mathematics, K.S.Rangasamy College of Technology. In this lecture video, let us see the topic skewness. Now let us see what is meant by skewness. Skewness is a key statistical measure that shows how data is spread out in data set. It tells us if the data points are skewed to left, it is negative skew, or if it is skewed to right, it is said to be positive skew in the relation to the mean. It is important because it helps us to understand the shape of the data distribution, which is important for accurate data analysis. Now there are three types of skewness. One is positive skewness, negative skewness, and zero skewness. What do you mean by positive skewness? In a positively skewed distribution, the right tail is longer than the left, which means most of the data points are on the left side, with few large values pulling the distribution to the right. In this case, the relationship is mean is greater than median greater than mode. Now let us come to that negative skewness. In a negatively skewed distribution, the left tail is longer, which means most data points are on the right with fewer smaller values pulling the distribution to the left. In this case, the relationship is mean less than median less than mode. Now let us come to the zero skewness. It is said to be symmetric distribution. Zero skewness shows a perfectly symmetric distribution where the mean, median and mode are equal. In symmetric distribution, the data points are evenly distributed around the central point, so all the values mean, median and mode are equal. Now let us come to the relative measure of dispersion. In relative measure of dispersion, we have the skewness coefficient, or we can say Pearson first coefficient of skewness. This is a numerical measure of skewness based on the relationship between mean and mode. It helps us to find if the data is skewed when the mean and mode are not equal. So, skewness equal to mean minus mode. Now let us see importance of skewness. Data interpretation. Skewness helps in understanding the distribution of data and identify potential outliers in unusual values. Statistical analysis. Skewed data can affect the accuracy of certain statistical tests, so it is important to be aware of skewness when using appropriate methods. And decision making. It gives understanding skewness with crucial in various fields like finance, where it can be impact investment decisions by highlighting potential risk associated with extreme values. Now let us see difference between dispersion and skewness. Dispersion measure the spread of data around the central value, that is mean and median. But skewness gives the shape of the distribution and the direction, left or right. Then in dispersion, variance, standard deviation, range, interquartile range is measuring. But in skewness, Pearson coefficient of skewness, moment skewness and QQ plots. In dispersion, it affects the means interpolation, but it is not directly related. Skewness shows the relation between mean and median. Like this, we will have some differences. Now let us come to the topic measure of skewness. In measure of skewness, we have two different types. One is Pearson coefficient of skewness and Bowley's coefficient of skewness. Pearson coefficient of skewness gives mean minus mode by standard deviation. If mode is not well defined, skewness equal to 3 into mean minus median by standard deviation. Bowley's coefficient of skewness is Q3 plus Q1 minus 2 into median divided by Q3 minus Q1. Now let us see an example how to calculate Pearson coefficient of skewness. The continuous data is given with some frequencies. For this, we have to find Pearson coefficient of skewness. Now let us take the true classes given in the problem, that is continuous interval. From this continuous interval, we have to write the mid value as x value and given frequencies as it is. Then we can calculate d. The d gives x minus a by c, where x is the mid value of the interval. A is the assumed mean we have to calculate. Then here a is 60. That is, since the number of interval is 1, 2, 3, 4, 5, 6, that we can take that A value among from this mid value of that thing. Then C is the interval, length of the interval, that is 20. Next we can find FD. We can find D square, then FD square. Now we can calculate summation F, that is total frequency, that gives 200, then summation FD, that gives 62 from the previous table, then summation FD square, that gives 416. Now let us calculate Pearson coefficient of skewness, that gives mean minus mode by standard deviation. We know that mean is A plus summation FD by summation F for continuous case into C. When I substitute all the values, we will get 53.8. That mode gives L plus F1 minus F0 divided by 2 F1 minus F0 minus F2 into C. That values I showed in the tabular column in the previous slide. So that is L equal to 40 lower limit, then F1 is the current frequency, then F0 and F2 everything. We can substitute, that gives the mode. Then standard deviation, we can use the formula square root of sigma FD square by sigma F minus sigma FT by sigma F whole square into C, that gives this value. Hence Pearson coefficient of skewness is mean minus mode by standard deviation. We will get 0.321. Now let us see Bowley's coefficient of skewness. Bowley's coefficient of skewness gives Q3 plus Q1 minus 2 into median by Q3 minus Q1. Similar way, we are having that class limit and frequency. Let us see how to find. Same manner, we are finding class limit, writing, then frequency we are writing, then cumulative frequency we can calculate from the given frequency. We all of you know how to find cumulative frequency. Now I am going to apply this formula. Now let us find Q3 class and Q1 class. As usual, you studied in previous lecture video. Then same manner we can calculate Q1. Q1 class gives n by 4, that value is 70. Then we have to check the value nearer to 70. Then we have to obtain L1, M1, F1, C1, Q1 from the previous table. So here L1 is 180, then M1 is 59, F1 is 52, C equal to 20 class interval. When I substitute, Q1 will get 184.23. Please refer that previous table. Now same manner we can calculate Q3 class, then its value gives 210, then we can check the nearer value in the cumulative frequency, then obtain all the L3 value, M3, F3 from the table, then we can substitute, we will get Q3. Then we have to calculate median. Median formula gives L plus n by 2 minus m by f into C. L we know that 200, f equal to 80, then m equal to 111, C equal to 20. Then median, if we substitute, we'll get this. So Bowley's coefficient of skewness is nothing but 0.027. Thank you for watching this video.